Alright, in this section here we're going to be talking about polynomials and rational inequalities, and we're going to be finding the solution sets to these inequalities. And so, of course, let's get started. We have x squared plus x minus 20 is less than 0. Okay? So remember that this whole thing right here represents the second coordinate of an ordered pair. All right. What we're going to do is we're going to go ahead and factor this thing. And so this factors to x minus 4 and x plus 5. We set each one of these factors. I'm just going to set them equal to 0 here. So we have x is equal to 4, and x plus 5, and x is equal to negative 5. Then what we're going to do is draw a number line, and we're going to plot 4 and negative 5 on the number line. So here's negative 5, and here is 4. And what we're going to do is pick I call these test points. We're going to pick a test point like 0, and we're going to come over here and plug it in and see if it's true. If I plug 0 in, you get negative 4. Plug 0 in, you get 5. And negative 4 times 5 is negative 20. So if 0 makes this true, it's a negative 20, a negative number, and it says it must be less than 0. Well, negative 20 is less than 0. So if this is true, okay, then that means that all of these numbers in between negative 5 and 4, if we were to plug those in up here, this would also be true. If you were to plug a number larger than 4 in, like for example 5 squared is 25, and 25 plus 5 is 30, and 30 minus 20 is 10, and 10 is not less than 0. Okay? So the solution set to this up here is going to be between negative 5 and 4. Now you notice I use parentheses here, okay, because this is not including the equal sign. This is just strictly less than, not including the equal here. So we cannot include negative 5 into this. If I did, you plug negative 5 in, we'd end up getting 0 here, and 0 times the number is 0, and 0 is not less than 0. See? Alright. Now, one way also to look at this is look at the graph. This is something we didn't talk about in the previous sections, but that is graphing this. And I think I'm going to graph this so we can get a better idea maybe of what we're talking about here. And so let's go ahead and graph that. Okay, so we're going to use Google's graphing utility. If you take this and type that into the Google address bar in a Chrome web browser, you will get this graph to come up. Now let's look at this. Here's negative 5, and here is 4. And remember, it's all the y values. I said the second coordinates that's less than 0, so that would be this graph, you see, that's below the x-axis, this part of the graph that's below the x-axis. So that's what we're looking at. This right here, okay, is my second coordinate, right? My first coordinate, second coordinate. So these numbers here, if you look at them, they're all below, they're all less than 0. So this is an easy way of looking at this. Now, if I were to zoom out, okay, you see that everything to the left of negative 5, okay, would be greater than 0, and everything to the right of 4 would be greater than 0. So if we were to flip this inequality around and make that greater than 0, then we would be looking at all of these x values. That would go from negative infinity up to negative 5, and then from 4 to infinity. So looking at the graph is a better way, I guess, of understanding this. And I'm going to throw this in because I didn't do this. But you know, in the previous sections, we were finding the solutions quadratic equations, and we were looking at where the graph crosses the x-axis. That's where y is 0. So you see where y is 0. Okay. Anyway, all right. let's look at another one here. We've got x squared plus 6x minus 7 is less than 0. So what I'm going to do here is I'm going to factor this. And this is going to factor to 7 and plus 7 minus 1. Right, because plus 7 minus 1 is a 6. When you multiply them together, you get negative 7. So we're going to set both of these equal to 0. So x is equal to negative 7. Set the other factor equal to 0. X is equal to 1. Now what we're going to do is draw a number line. And we're going to plot. We'll put negative 7 here and 1 over here. And then we're going to choose a test point, which I call a test point, like 0. We'll choose 0 there. So you want to take 0, plug it in. Let's plug it into the factored one here. So 0 plus 7 is 7. 0 minus 1 is negative 1. And 7 times negative 1 is a negative number. And that means it's less than 0. So that means that this stuff in here is going to be our solution. All the numbers between negative 7 and 1. And so let me so our solution set, I start with a parentheses because we don't include negative 7. And with parentheses, we don't include 1. So this interval right here represents the set of numbers between negative 7 and 1. We can use any of these numbers in here that will make this true. Now, I've been graphing, and I think that's what I'll do. I think I'll graph this so you can better see what it is. You should know how to find the vertex of this parabola. Find the zeros. These are what are known as the zeros, where it crosses the x-axis, and be able to kind of sketch the graph from there. But save some time. I'm going to... Alright, so we've graphed it where it crosses the x-axis. Those are what are known as our zeros, which happen to be negative 7 and 1. Remember, this was less than 0. So we're looking at all the y values that are less than 0. So that'll be all the stuff in between negative 7 and 1. See that? So you can just, clearly look at the graph and tell, what your solution is going to be here. Alright. Okay, so let's look at another one here. Clear the board. Maybe center this thing if we can. There we go. And let's see what I got in store on the next one here. Alright. Let's see what we got. We've got 5x squared minus 9x is greater than or equal to 0. Alright, so this is an easy one here. I'm going to factor this x out. We're going to be left with a 5x minus 9 is greater than or equal to 0. So we set both these factors equal to 0. Well, that one's easy to solve. And then we've got 5x minus 9. Set that equal to 0 and we get x is equal to 9/5. Alright. So then what we want to do, draw a number line. We'll plot 0 on the number line here and 9/5. Alright, we need a test point. And how about 1? 1 would be a good test point here. So I'm going to take my test point, plug it in up here. Alright, plug 1 in. So x is 1. 5 times 1 is 5, and 5 minus 9 is negative. Alright, so we plugged in our -1. I'm sorry, plugged in our 1 right here. And we get a negative number, plugging in 1, so we get a negative, and a negative number is not greater than or equal to 0, so we know it's not this stuff here. So it has to be the stuff on the outside. So all of this stuff here is going to be our solution. All right. And of course we're going to write it like this. Negative infinity up to 0. And now we include 0 here. Got to greater than or equal to. So we include it. And this symbol here means union. We just join both sets together. And of course we include 9/5 to infinity. Alright. And I think we're going to look at a graph on this. You can kind of see what this looks like. Alright, so this is the graph. Now we said it's all the stuff outside of 0, everything to the left of 0 and to the right of that 9/5 is actually 1.8, which is nice. It's right here on the graph. What we're going to do here is we're going to zoom out, because it was everything less than 0 and everything greater than, or I should say less than or equal to, and everything greater than or equal to 9/5. Right? This stuff here is all the stuff less than 0, right? And remember, these are the numbers we're looking at here. But our solution are x values. You know, the solution, that interval, are x values. So remember, this was greater than or equal to 0 up here. All right, so it's nice to be able to look at a graph and tell, you know, get an idea of what we're looking for. Okay. All right. So we have 10x squared minus 41x plus 21, and that's going to be less than 0. So what I'm going to do here is I'm going to use the quadratic formula. Okay, and let me just write that up to refresh your memory. So that's b squared minus 4ac all over 2a, and remember, this is a, this is b, and this part is c right here. Right? But I think before we do this, let's first look at the graph. Okay, let's look at the graph, and then we'll come back to this. Alright, so here's the graph we're looking at. And you remember that this is less than 0 here. Okay? So that means we're looking at the graph that's below the x-axis. And it looks like it's 3.5 is going to be one of our zeros. And this would be 0.6 right here. So it's looking like between 0.6 and 3.5. Okay, so when we go to set this equal to 0 and solve for x in this problem, or actually, you know, that's what we're doing, but we're going to find the, we're going to use, the quadratic formula to do that. All right. Okay. So let's just do that. I'm going to have x is equal to negative b, and b is negative 41. So let's start with parentheses. And it's plus or minus the square root of negative 41 squared minus 4. A is 10. And C is 21. Right, and it's all over 2 times 10. Alright, so I'm going to get out my calculator. You can do that in your head if you like. This is a negative and negative, so we know that's a positive 41. Plus or minus. Alright, I'm going to go ahead and work that out. Alright, so underneath the radical here, I am getting 841, and this is all over 20. And so we're going to have square root of 841 is 29, and that's all over 20. We'll write the rest up over here. So we have x is equal to 41 plus 29 over 20. And what do we get with that? It looks like I'm getting 3.5 or 7 halves. So excuse me, remember this is 3.5. And then we have x is equal to 41 minus 29 over 20. And that's going to end up being 0.6, or we would say 3/5. And I think, we looked at the graph earlier on that, and that's what we've seen. So here's the two solutions to those equations. What we're going to want to do now is draw a number line, and I'm going to try to sneak that in right here. See if we can sneak that number line in right there. Okay. So this was 7 halves, and then this over here was 0.6 or 3/5. So it's 3.5 and then 0.6 right here. Which means that, okay, let's do some testing here. Let's try a 1. Okay. If I were to take 1 and plug it in, now we'll just plug it into here. We got 10 minus 41, so that's negative 31. And then negative 31 plus 21 is going to be a negative number, and that is less than 0. Alright, so remember our graph was below the x-axis between 3/5 and 7 halves. So that means it's all this stuff right here. Okay? And we just write our interval. We don't include 3 halves. And we don't include 7 halves. Did I say 3 halves? Is that right? I forgot what I was doing there. 3 halves. Yeah, 3/5, I mean. Not 3 halves. I think something was fishy there. 3/5. I said 3 halves, but it's 3/5. Alright, and 7 halves. So we had to use a quadratic formula on this one. Of course, looking at the graph helped out, but I'm sure if you were taking a test, you wouldn't have time to graph it out or anything like that, so you just got to follow these same steps. Alright. Okay, so this should be like a quiz question here. Finding the solution set to this inequality. So what I'm going to do here is I'm going to go ahead and multiply both sides by 1/9. And then we're going to square root both sides. Okay. Actually, you know what? I'm going to write it like this. Square root both sides. And I know it doesn't include the equal sign, but don't worry about it. So x is equal to plus or minus. That's going to be 4/3. So x is equal to plus 4/3 and x is equal to minus 4/3. So we go ahead and graph this out. I'll put the minus 4/3 here and the positive 4/3 over here. And let's pick a test point. We're just testing this interval here like 0. We plug it in as 0 greater than 16. No, so it's not this stuff, so it's got to be all the stuff outside. It's all of that stuff outside. Alright? And so that interval will be between negative infinity, negative 4/3, union 4/3, positive infinity.